Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Variation of electric potential in a region is shown in the graph below. Find the magnitude and direction of the force on a particle having a charge of plus 2 microcoulomb just after it is released at a point x is equal to 1 meter in the region. So a graph is given to us between the potential difference in volt and the distance in meter. So let us just mark the points on this graph. So this is my point A, and it is having the coordinates as 0, 10. And this is point B. It is having coordinates as 2, 0. We know that slope of this graph can give us dv upon dx, and that can be calculated as y2 minus y1 divided by x2 minus x1. So this is my B point is x2 y2 and A point is x1 y1. So I can write y2 minus y1 as 0 minus 10 divided by 2 minus 0, and that will give me minus 10 upon 2. That will be equal to minus 5 volt per meter. And we know this thing that electric field E, it is equal to negative of dv upon dx. So I can write E as minus of minus 5. That will be 5 volt per meter. Since the value of electric field is independent of distance, at x is equal to 1 meter, we will be having the same value. So E is independent of distance x, and hence at x is equal to 1 meter, E is equal to 5 volt per meter. Now we have released a charged particle of 2 microcoulomb at x is equal to 1 meter. We need to find the force acting on this charge. So force F is equal to Q times E, and that will be equal to 2 multiplied by 10 to the power minus 6 multiplied by 5. So the value of F will be 10 multiplied by 10 to the power minus 6, and on solving it out, it will be 10 to the power minus 5 Newton. So this is the magnitude of force that is acting on the charged particle when it is released from a point that is x is equal to 1 meter. Now we also need to give the direction of this force. So we know this thing, the direction of electric field is always towards the decreasing potential. And I can see that when I move towards the positive x-axis, the electric potential decreases. So E is acting along plus x direction, and since the charge is positive, the direction of force will be along the direction of electric field, and that is along plus x axis. So this is the direction of force on this charge. If the magnitude of this charge would have been negative, then the direction would be towards the negative x-axis, because for the negative charge, the force is always opposite to the applied electric field. But for the positive charge, it is in the direction of the applied electric field. And that's the answer for this question. Keep learning, keep practicing, keep excelling.